We are discussing solutions for LeetCode Biweekly Contest 125. Jump to specific questions using timestamps in the video description. Like and subscribe if you enjoy my content and to stay up to date on new videos. Today's contest is interesting. I think question 1 and 2 were, I think most people agree they're fairly easy. Question 3 is complicated. It's not that hard, but it is very complicated. It's very confusing. Question 4, I don't think question 4 is that hard, but unfortunately I ran out of time to do it. Overall, I think I like this week's contest. There were no like weird mathematical puzzles, and there were no like 8-point and 9-point questions, as they sometimes are. With that, let's get into question. We're going to do question 2, 3, 1, and 4. Because I think that's the sequence that works out. So with that, let's get into question 2. Oh, you can see my Matt Piper. Okay, for question 2, let's start by reading the question. You're given a 0-index integer array nums and an integer k. In one operation, you will take the two smallest integers x and y in nums, remove them from nums, and then add this new thing, min xy times 2 plus max xy, anywhere in the array. Okay, so basically you're given a bunch of numbers like this. You take the smallest two, you take them out, and then you add this new thing in. So minimum times 2, which will be 2 plus 2, which will be 4. So you add the 4 in. So essentially this question is it sounds complicated, but it's not super hard. Essentially what you need to do is you need to just do these operations in turn until this happens. All elements of the array are greater or equal to k. So the way I did it is to use a heap. In Python, there's this thing called heap queue, which essentially is a heap. In Java, you can use a priority queue. It's the same thing, right? The reason why you want to use a heap or priority queue is because you're always collecting the two smallest items. You're collecting the two smallest items and you're adding a new item. And when you add a new item, like you can see here, when I add the 4 is not added at the end. It's not added in the beginning either. It's added somewhere in the middle. You don't know where this new number is going to be added. So because of that, what you have to do is you have to essentially keep the list sort of sorted so that you can always pick up the first two items quickly. So that's why you need either a heap or you can use a priority queue. So the code itself is not that complicated. Essentially, you have a heap. If you use a priority queue, I think you have to sort it first, but heap you don't need to. And then what you do is while length is greater than 2, you take the two smallest numbers in the priority queue, you pop them out. If the first number is larger or equals to k, that means you're done, right? Because the first thing you pop is the smallest number left. And if that guy is larger or equal to k, everybody else is larger or equal to k. So you're done. If not, then you say, count equals count plus 1. That's the number of steps you need to take. And you take a new step. You calculate the new guy, which is the minimum of xy times 2, plus minimum of xy. And then you do a heap push. So in the priority queue, there's some other, depending on what your API is, it looks a bit different. And then finally, you return this count. So I'm pretty sure if you do like a regular list, you will run out. You will get TLE. But if you do a priority queue or you do some kind of heap, then you will not. Yeah, there is a super interesting. Yeah, any questions in the chat about question 2? There was an interesting question. I think HX asked the question about whether you can use a heap in a coding interview. That is a great question. It really depends. It depends on the coding question. I think so. For those of you who don't know, I've been in big tech for 10 years. I was at Google for 10 years, and I interview a lot of people. So my rule is, if the question, if you use a standard data structure, I would like you a lot. I would say, yes, this person is great because he or she knows that this data structure exists. So I love it when people use standard data structures. That said, if the standard data structure makes the question trivial, then what I might do is I'm going to ask you to explain to me how it works. So you can use so basically TLDR, you can use a heap. You shouldn't have to re-implement the heap. If the interviewer makes you re-implement the heap, that's not a very good interview. But you should be able to explain exactly what the heap does and how it works. You should be able to convince the interviewer that you know how to implement it. If you're able to do that, then there's absolutely no reason why he will not let you use a heap. Yeah, I hope that's helpful. Okay, let me just read the chat quickly. Yeah, LeetCode versus dev. Yeah. Okay, so let's jump to question 3. And then after question 3, we'll do question 1, and then question 4, and then question 1, one of the two. So question 3, count pairs of connectable servers in a weighted tree network. You're given an unrooted weighted tree with n vertices, represent servers 0 to n minus 1, and array edges, where edges equals to blah. You know, they're weighted, so the left edge, x, y, and then the weight. It's a bidirectional edge, so there are no arrows. You're also given integer signal speed. So two servers A and B are connectable through a server C if A and B are different, A, B, and C are all different, and the distance from C to A is divisible by this, distance from C to B is divisible by signal speed, and the path between CB and CA do not share any edges. This is actually really important. So essentially, you want C to be the middleman, right? C is the middleman. C should connect to A, C should connect to B, and then the distance between CB and CA are divisible by signal speed, and the paths between these two things don't share any edges. Okay, this sounds complicated, but it's not. Graph problems, first thing you do is to draw the graph. If you don't draw the graph, if I don't draw the graph, I have no idea what it's talking about. Okay, so the finally you want to return integer array counts of length, where counts I is the number of server pairs that are connected through the server I. Yeah, so everybody takes turn being C. Everybody takes turn being the central server C. Okay, let's look at this one. Let's look at this one. Okay, so for instance, this one. Sorry. Let's say C is this 2 over here, okay? Let's say C is this 2 over here, okay? Let's see C is the central one, okay? So let's say A, let's pick something for A, right? Let's pick 0 for A, right? 0 for A. And the distance between them is 5 plus 1 is 6. Since signal speed is 1, any distance is fine. So everything is divisible by 1. So let's say A is here. So where is B? Where can B be? Can B be 1? B cannot be 1. Because if B is 1, then they will share an edge. And you want CA and CB. If B is this, then, this is A and this is B. And then this becomes a shared edge. So you don't want, so B cannot be 1, okay? If A is 0, then B has to be the other side. It has to be somewhere here, right? In order for A, C, and BC to not share any edges, A and B has to be far away from each other. They have to be in like a separate subtree. Does that make sense? They have to be in separate subtree. So essentially, the first thing you want to do is to think about is to basically select A and B. So let me not jump ahead first. So in this case, let's say A is here. Where can B be? B can be here, here, or here. Okay? So it's 0, 3, 0, 4, 0, 5. That's 3. And then if A is here, where can B be? B can be here, here, here. So I have 3. And then now I have 4, 5, 6. Total 6 possible counts. Okay? So that's why this number here is 6. So that's how the solution is gotten. That's what this problem is asking for. Essentially, the problem is asking, okay, you see this is a list here, right? This is a list. It's 1 to 0, 4, 6, 6, 4, 0. Essentially, what it's asking you to do is to let each node take turn being C. When 0 is C, what happens? When 1 is C, when 2 is C. And for each C, you count how many possible pairs of A and B there can be. Okay? So that's the basic idea. Okay? Let's look at this one, for instance. So let's say this is C, right? This is C. Okay? If this is C, where can A be? If A is here, here, or here, basically if A is in this quadrant, then B must be in one of these quadrants, right? A and B cannot be in the same quadrant. If A is in one of these 3 nodes, and B is also in one of these 3 nodes, they're going to share edges. So you don't want AC and AB to share edges. Okay, so Aniket has a question. Let me answer it real quick. So why is this 4? Oh, the first index, why is this 4? Okay, so when 1 is the server, right? A can be here. B can be here, 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 or here. So you have 0, 3, 0, 2, 0, 4, and 0, 5. Okay? You have 4 possible pairs of A and B. So when A is here, B can be any of one of these 4. When A, right? So that's 4. When A is anywhere else, when A is here, B cannot be any one of these, right? B cannot be here, cannot be here, cannot be here. It can be here, but it's already here, right? So that's how you get the number 4. Does that make sense? Okay, cool, awesome. Okay, so back to here. So when A is in this quadrant, B has to be in a different quadrant. So now we are seeing the pattern, right? We're seeing the pattern. The pattern essentially is we're going to divide the world. For each server C, we're going to divide the world into quadrants based on which child they come from. So for instance, for when the server is 0, when C is 0, you have 2 quadrants, 2 worlds. This one and this one. When A is here, B has to be here. When A is here, B has to be here, right? A and B cannot come from the same quadrant. So that's the first constraint. The other constraint is that the distance between the distance AC and BC are both multiples of signal speed. In this case, signal speed is 3. Okay, signal speed is 3. So in C, in this first quadrant, 6 and 5 both have distance multiple of 3 from C. So this is distance 3 and this is distance 6. So both 6 and 5 are multiples of 3 distance from C. In this second quadrant, only 4 is multiple of 3 away, right? So this is 1 plus 7, this is 8, so we can't have this. This is 1 plus 6, this is 7, also no this. This is 1, also no. So only 4, 6, and 5 are allowed. So now you know that A and B has to come from different quadrants. Then it stands to reason that the total number of combinations of this is going to be 2 times 1, which is 2 over here. Yeah, A equals to B. So the A equals to B is just means that A, like they don't want to make it such that 0, 4 and 4, 0 both appear. You don't have to actually care about A equals to B, B equals to A. It just says that A and B are different, and you don't want to count the same thing twice. If you have 0, 4, you don't want 4, 0. That's all it's saying. That's what all A smaller than B is saying. You don't want to double count. Yeah. Okay. So does that make sense? Right? Let's give another example. Okay, so this one, 6. So when C is 6, you have one quadrant, one more quadrant, okay? So this quadrant, this is allowed because it's distance 3. In this quadrant, 0 is allowed. I think 4 is also allowed. So there's 2 here and then 1 here. So again, it's 1 times 2 to give you 2. Okay, I'm going to add one more example. It doesn't appear here, but it's a bit complicated. Let's say this is the server, right? You have this. Okay? Let's say signal speed is not 3 but 1. Okay? So all of these are allowed. So this is 3, 1, 1, 1. How do you find the number of pairs? Well, this becomes very tricky now. Essentially, what you have to do for this, if you have 3, 1, 1, 1, you have to pick any 2 combinations of them and multiply them together. So this is going to be 3 times 1 plus 3 times 1 plus 3 times 1 plus 1 times 1 plus 1 times 1 plus 1 times 1. So you add these things all up. Okay? You have to do every pairwise combination of all the 4 quadrants. So basically, you divide the world into quadrants, find out how many eligible nodes are there in each quadrant, and then you multiply, you do like a big multiplication. You select any 2 quadrants and you multiply them together, and then that's the sum. Okay, so that's essentially what I did. There are some optimization I did along the way. So I'm going to talk about the code. The code is actually really long this time. I'm going to see if I can explain it in a good way. So the first thing I did actually is a bit of a cheat code. I'd recommend you do this every time you see a graph problem, which is you turn this list of lists into a dictionary. So you guys know about edge list versus adjacency matrix, right? Essentially, I turn this edge list into this dictionary, which is an adjacency matrix. Because adjacency matrix is much easier to work with for this particular problem. So once I have the adjacency matrix, I throw away the original edge list. I don't care about it. So the next thing I want to do is for each source in range, I'm going to do this thing. I'm going to find all children, right? I'm going to find the edges of source for each edge in source. So source is the central server, and you sort of take turns doing the server. And then condition A, is you sort of take turns doing the central server. And when you're the central server, what you do is you find all child, you like divide your world into quadrants, and then you find all the children in each quadrant. That's what this function is doing, which I'll go through in a bit. Okay? And what you do is, after I do that, I just find all the children that are eligible. So here, I find all the 4 quadrants. I find all the children that are eligible. Like this is eligible, this is eligible. I don't know exactly. This is eligible, right? And then I sum them up. So, let's say in this example, this would be 2, this would be 0, this would be 1, this would be 0. So I find all the children and I find which ones are eligible. Eligible means the distance between them between C and that guy is divisible by signal speed. And then I add them to this counts. That's what this counts is doing. And once I have the counts, I do this nested for loop. So once I have the counts, for instance, this count is going to be 2, 0, 1, 0. Okay? So if this is the count, I do a nested for loop. I take pairwise multiplication of all of them and sum them up. So that's what this piece of code here is doing. It's doing pairwise multiplication. Because what you want to do is you want A and B to come from different quadrants. And you take every quadrant, every pair of quadrants, you multiply them together. Okay? And then that's what gets you the total. So now this find all child is basically a depth first, it's breadth first search or depth first search, whatever you want to call it. I think I did a DFS, but you do DFS is exactly the same. What you do is I have a done. You guys know depth first search, right? So done, source, and cost. The only thing is in the depth first search, I keep track of the costs. So I'm not just going through all the nodes. I'm also keeping track of what's the distance it takes to go from the source, which is C, to the new node. Okay? So yeah, this part is fairly standard. I don't think there's anything to do. You can use Warshaw-Floyd, but I don't think you need to use Warshaw-Floyd or Floyd-Warshaw because this is a tree. This is not a graph. So Warshaw-Floyd is important if there are cycles. Because there are no cycles, there's exactly one path from every node to every other node. So you don't need anything fancy. You just go through the whole thing. You do a depth first search, you get the answer. Okay. Any questions about this? Let me see. There's some activity in the chat. Multiply all the counts. Yep, all the counts and branches. Count the product of the pairs. Oh, yeah. You multiply all the counts in the branches, it won't work. Yeah, it's not gonna work. You have to, you do the sum the product of the pairs. Exactly, yes. Not just array. So it's not that silly because I also did this at the beginning. I also multiplied them all together and realized, hey, you can't do that. You have to do the product of the pairs. So I did the exact same thing as you read finance. Except you are in high school, so you are very impressive. Condition should be less than B. Yeah, so, the A and B doesn't really matter. Which one is A, which one is B. Just make sure that you don't count them twice. You count AB, you don't count BA. That's all this condition is doing. Okay, so, yeah. If there are no more questions regarding... I actually like question 3 a lot. It's a very fun question. So if there's no more questions regarding question 3, if there are, write in the chat. If not, then I'll go on to question 1. Yeah, Sandeep, you're new to graph. Yeah, you're new to graph. I strongly recommend everybody learn some graph algorithm for 2 reasons. One is it comes up a lot in these kind of programming problems. It will definitely 100% come up in a tech interview, right? If you're trying to get a job from a tech interview, graph questions come a lot. If they are not graph questions, there are 3 questions, which is basically some kind of graph. So knowing your graph, like basics, is very important. Yeah, the graph and tree, they're very related. You can also learn some like standard algorithms, but if you don't know the standard algorithms, I think it's not that big a deal. But you need to be very familiar with how graphs and trees work. Yeah. And yes, being an actual dev is very different from LeetCode. I have so much to say about this. And I will release a video next week talking about this exact topic. So look forward to it. Okay, so question 1. Okay, hang on. Let me answer more questions. So hey, Jack, do you have any recommended resource for learning about tree graph related algo? That's a good question. I don't have it, but I'll look it up. There are fairly standard. I'm gonna give the answer that's like fairly standard courses that you can take online, but I don't know. I'll look it up to see if there's a good one. So I can tell that there's a lot. There's a lot, but the problem is they all cover something slightly different. And you don't know which one is the best, and none of them are really comprehensive. So, yeah, I don't know. So, important graph algorithms for learning. The most important one is graph traversal. So, DFS, BFS, knowing how to find the shortest path. So, the Warshaw-Floyd, Floyd-Warshaw, Dijkstra's algorithm, those are the most important. Finding cycles. You want to detect how many cycles there are. You know how to count how many connected components. Those are very important. And those are actually really important when you write production code. You're not going to write them yourself, but you need to know that these algorithms are out there so you can use the library. Like if you know a network admin, you want to check that all your servers are connected together, do a DFS, right? Obviously, you're not actually going to do it yourself, but you will need to know that these libraries exist and that you can use them. Okay, let's go to question 1. Minimum operations to exceed threshold 1. So you're given a 0 index nums and an integer k. In one operation, you remove the smallest number, and then you count how many times you have to do this before everybody is larger or equal to k. Well, this question, you actually don't have to do any sorting. You don't have to remove anything, right? The difference between this and the next question, the biggest difference is actually the next question puts something back. This guy does not put anything back. And because it doesn't put anything back, it is much, much easier. You don't even have to sort it. All you have to do is count how many numbers there are smaller than k. If your k is 10, how many numbers are there smaller than k? 1, 2, 3. 3 numbers smaller than k. Well, you have to do the operation 3 times. If your k is equals to 9, how many numbers are there smaller than k? 1, 2, 3, 4. Operation 4 times. So that's it. So this is supposed to be the easiest question. You just count, and for each n in num, if k equals 1, count. You can get fancier than that, but like this is the easiest to read. It takes you like a minute to solve. Okay. Let me see. Any other questions in chats? Yeah. Okay. So the last thing is question 4. So just a quick curiosity. Anybody managed to, how far did people get in question 4? So I know Kushaw. I don't know if Kushaw is still around. Kushaw seems to have gotten a bit, Kushaw who saw, I'm sorry if I'm saying your name wrong. You seem to have gotten some part of the way there in question 4. If there are 29,000 people in the contest, how come there's not 100 acceptance? You know, some people actually just register a contest and they never show up. So kudos to you guys for showing up and actually finishing the contest. That's all I want to say, right? Doing the work is, like, showing up is most of the work. So I'm very proud of you guys. Okay, find the maximum sum of node values. Okay, this one actually I haven't finished yet, but I will tell you, I will talk about what my intuition is and what I think is the path forward. Okay, but because sometimes I sleep through this contest. Oh my god, I cannot sleep through this contest. I have no time. It is always a struggle. Yeah, so if there are people in the chat who have better ideas for solving question 4, definitely let me know. Post it in the chat. I'll be excited to hear from you. Okay, so question 4. Find the maximum sum of node values. There existed an undirected tree with nodes 0 to n minus 1. Each of the nodes, so they are edges, and each of the nodes have values, right? Have values n, where nums I represent the value of nodes number I. Okay, so what you want to do at each time is you want to choose an edge, U and V, and you want to change the graph by doing the following. You take the value of u and you XOR with k. You take the values of v and then you XOR with k. Okay? So you're XORing both sides of the graph. So take for simple example this one. Okay? So this is node 0, node 1, node 2. These are the edges. So they're already displayed here. These are the values. They're not displayed here. So the values of this is 1, 2, and 1. Okay? And k is 3. Oh, oops. So k is 3. So in case I've never said this before, I actually hate binary problems because they're so tricky. Yeah. So I just write them out here because it makes me easier to see. Okay. So what do we know when I take 1 and I XOR with 3? So 1 XOR 3. So you guys know what XOR is, right? 0, 1, 1, 1. You XOR this becomes 0. This becomes 1. Essentially, XOR says if there's a 1 bit in the mask, in this k mask, then you flip the bit. So I'm flipping both bits. So the property of XOR is that when you XOR something twice, it goes back to the original number. So 1 XOR with 3 will give you 2. And then when you take 2, you XOR with 3, you go back to 1. So essentially, the way I think about it is I kind of hate the XOR. But the way I think about it is I think that every node has 2 values, the normal value and the complementary, which is XOR. Right? Because you XOR the complementary, it goes back to original value. So it goes through between the 2. Okay? And so what happens now? What happens now is you want to maximize the value of the graph by choosing edges to XOR. So the thing is, so obviously you can XOR each node individually, then just pick the larger one, right? Then you're done. But unfortunately, you cannot do that. You can only pick edges. So the edges mean that you have to XOR both. So for instance, if I pick this edge, I have to XOR this guy. This guy will become 2. Let's pick a different color. So if I XOR this edge, this will become 2, and this will become 1. So that's not going to help me. That's not going to help me. This guy became bigger, but this guy became smaller, and total is stay the same. But if I XOR this edge, this becomes 2, and this becomes 2. Both of them become bigger. Yay! Great! Perfect. Yeah? So both of them become bigger. So this means that I don't think a greedy algorithm to work. So essentially what you have to do is to find the edges that you want to XOR. And the value of each node depends on how many edges next to it are selected. So for instance, this one, right? If I select 2 of them, then this one will be will flip back to the original number. So I think that's the game that we're playing here. But I don't know how to solve this in a tractable way. Because if you pick the number of edges, right? You pick the number of edges, it's actually 2 to the power of n. That is a very big number. 2 to the power number of edges. So that just seems too big for me to figure out. Yeah, especially when n, the number of edges is n minus 1 is like this big ass number. So I think there should be some dynamic programming solution. I just don't know what it is. Yeah. So I'm going to try it out in some of my own time and then see if I can figure it out. Yep. Okay. So yeah, that's it. That's it for the contest. So once again, thanks for everybody for hanging around. Thanks to everybody for being so vibrant in the chat. This is one of the most talkative chats that I've had in a long time. Is always heartwarming to see. If you have not, if you enjoy my content and if you're not subscribed, please do. It helps me out a lot. Yeah, no problem, Red Finance. I hope to see you again next week. Yeah. I'm going to release a video on like interview and LeetCode soon. And hopefully that's something that you guys will be interested in. If any, yeah, thank you very much for HX. And by the way, if you guys want to reach out and you want to ask questions, just comment on any of my videos. I will answer the comments. So I don't get, I'm a very small subscriber, small content creator, so I don't get a lot of comments. If you comment, I will answer you. Okay? All right, cool. Thank you very much, everybody, and see you guys next week.